Millionaire. Like I said, we've been talking about compound interest. We have Greta, Trisha, and Steve. They're investing money in hopes of becoming millionaires. All accounts have an annual compound interest. Remember, we talked about finding interest. It adds it back in, and then the next year you get interest on the interest plus what you originally had. So Greta invests $2,000. That has a 10% interest rate. Trisha, $1,000. That has 15% interest rate. And Steve, $2,000 with a 5% interest rate. So before we do anything, I want you to write down, do you think Greta, Trisha, or Steve will hit $1 million first? This is purely a guess. Take a moment, think about it, write down a name. All right, so we're going to do some practice today writing our equation. Keep in mind, y equals a times b to the x. So Greta, remember A is your initial amount. What was Greta's initial investment? Y equals, so our A is 2,000. And then remember on this B, it's going to be 1 plus that percent as a decimal. So how do we write her 10% as a decimal? 0.10, right? So what is her B? What is her growth factor? We got 1 plus 0.10. So 1.1 essentially to the x power. And what this is saying is she gets her 2,000. Remember when we broke it out last week? This is our 100%. This is where that 1 comes from. Plus she gets that 10%. So what about Trisha? What is her initial amount or her A value? 1,000. What is her growth factor? 15. So we got to make it a decimal, 0.15. So our B value is 1.15. Because it is a growth, this is going to be bigger than 1. So this is, again, her 100%, her $1,000 investment plus her 15% growth. What about Steve? What is his A value? 2,000. What is his B value? 1.05, because 5%, 1, 2 is 0.05. All right, any questions on how we got those equations? Does anyone want to change their prediction? All right, let's look at part C. Greta tells Steve that he did not invest his money well. Steve says that the percent growth is not a big deal. He says in 10 years, we'll both have a lot more money. You will just have 5% more than I do. Do you think Steve is right? No. Show Steve why this statement is incorrect, and then you got to figure out how much more percent-wise Greta has than Steve. So, well, where do you think we should start with this? If we're talking about 10 years, what do we need to do? Good. We're going to put 10 for our exponent. So I'll make a little note here. So Greta, we put 10 in our exponent. So we have 2,000 times 1.1 to the 10 power. We can go over here to our handy dandy calculator. Oh, I hit a button. All right, let's try calculator. So we're going to say 2,000 times 1.1, and then remember we're using that little caret to the 10th. And she has about $5,187 in 10 years. After her $2,000 investment, that's over $3,000 in interest. Now remember, that's only if she doesn't touch it, right? She just leaves it there and it grows. So we'll write here, so Greta after 10 years has $5,187. How are we going to figure out how much Steve has? You can round it, that's fine. Y equals, he also has 2,000, but his is 1.05 to the 10th. Put that in your calculator. All right, so 2,000 times 1.05 to the 10. He has 3,200. We'll call it 57 or 58. I'm thinking Steve is wrong. All right. So Greta will have what percent more money than Steve? How are we going to figure that out? We're going to divide them, right? So we can go in, let's use our calculator because that just makes life happy. 3258 divided by 5187. Put a decimal on there if you want. I'm at 0.628. Now that's a decimal. How do we write it as a percent? Move the decimal over. So about what? We got to move it over twice. 1, 2. So it's about 63% more money than Steve. That's way more than 5%. Remember when we talked about this last week? That compound interest is going to grow, grow, grow. Okay, which is really good if you're investing money. But if you owe money for a credit card, the same thing happens, right? So it's really important not to get into debt. All right, create a graph. We're not actually going to draw the graph. We're going to use our calculator and identify who becomes a millionaire first. So to do this, I want you to go back up to your equations, and I want you to have your calculator next to you. We're going to start a graph. Do you remember how to put in multiple graphs here? Tab. So we're going to say 2,000 times 1.1 to the x power because we want to see what it, and you're not going to be able to see it on here yet. I'll show you how to fix that. Tab. For Trisha, we had 1,000, right? 1,000 times 1.15 to the x. And then tab again, so we're on the third one for Steve. We want to see all three of these side by side, 1.05 to the x. Now, again, you can't see them. Does anybody remember what we need to do? Menu what? Menu for, you can zoom out, or if you go down here to A, it will size it for you. It just takes it a minute. Oh my goodness. Look at that. So you can see here that the blue line is Greta, the black line is Steve, and the red line is Trisha. Okay, how do we what? All right, looking at this graph, if you wanted, you can also, if you wanted to see further off to the side, you can do menu 4, and you can zoom out a little bit more and you can see, obviously this is Steve. His is not growing very fast, but you can see between Trisha and Greta, whose is growing faster, the red or the blue? The red. And who was red? Trisha. So she is probably going to hit $1 million a lot faster than the other two. So let's figure out how long it will take for that to happen. I want you to go to the calculator. Number 1, we're going to use NSolve to help us figure out who is going to be a millionaire first. And we have Greta, we have Trisha, and we have Steve. And in this case, in place of Y, how much money do we want them to have? 1 million. So our Y is $1 million. So we're going to say 1 million is equal to 2,000 times 1.1 to the x, and we're going to put it in NSolve, comma x. And we're going to figure out how many years it will take based on this investment. You're going to have to arrow down to get that comma x. I'm going to show you. So when we go over here, how do we get to NSolve? Do you remember? Menu 3, 1. So we're going to start with Greta. So make sure you have enough zeros. It's 3, 4, 5, 6 zeros equals 2,000 times 1.1 to the x. But now you have to use that right arrow and tell it comma x. How many years? It's a lot of years. 60, we'll call it 65 years. How much? So we're going to do the same thing for Steve. Menu 3, 1, 1, 2, 3, 4, 5, 6. Oh no, his was 1,000, wasn't it? Oh no, this is Trisha. 1,000 times 1.15 to the x. And remember, arrow down, comma x. How long for her? 49 years. That's a little more doable. And then Steve. Oh, sorry. 1,127 years. I don't think Steve is going to meet his goal. He might. 127 years. So who predicted that Trisha would hit $1 million first? Very nice. Why? What made you choose her over, say, Greta? She didn't invest as much money. She had a higher interest rate, and that makes all the difference. When we talk about growth and decay, I want this for tomorrow, please. Remember, we're talking A, B to the X, where A is our initial, and this is our growth rate. Now, couple of things. If your growth rate is between 0 and 1, this is going to represent a decay. Doesn't that make sense? If it's going down, if it's less than 1, it's going down, so that would be a decay. If it is greater than 1, it is a growth. Now, how do we decide what that would be? So I'm going to give you a couple of answers here. All right, on this first one, it gives you the equation 1,200 times 1 plus 0.3 to the t. Do you think this is going to be a growth or a decay? This is going to be a growth. All you have to do is circle it. What is your initial value? What is your A value? 1,200. Okay, so this is the only part that's a little tricky. We know it's a growth, but what is the rate of growth? 30%. Good. And the reason it is 30%, remember, this is your 100% represented here. This is your growth, and we have to change it to a percentage. Do we see that? Just like when we had the 15%, we wrote 1.15. In like manner, sometimes we have a decay. Look at number 2. This says 1 minus 0.02. If we were to simplify this, we would have 55 times 0.98 to the t power. Notice that this growth rate is less than 1, so it's a decay. Our initial value is what? 55. Okay, so this is where it gets tricky. What is our rate of decay? It is not the 98%. It is your growth and decay is always what is added or subtracted from the 1. So this is going to be 2%. Do you want me to do 2 more with you? All right. If you're good, then you can do that. All right. Let's just do this. This is obviously a growth. What is our rate of growth on number 3? Good, 25%. This is a decay. Be careful here. What is your rate of decay? Be careful. Remember, this is 1 minus what is 0.65? 1 minus something is 0.65. 35. So this is our growth, or our decay rather. What would it be?
35%.
Okay? I want this done when you come in tomorrow.